Hello, class, and welcome to Module 1. In this module, in this module video, I will go over the important information that you need to know and some helpful tips to help you get through the different assessments. In this module and in all modules, you will see that there are CLOs listed, and that stands for the course learning objectives. Those you will find in the syllabus. We're going to be working on CLOs 1 through 5 for this particular module. And while there are no date restrictions on your modules, focus on completing this before the second week of class if you want to stay on a weekly schedule. You will also see the due dates under each module activity, and these due dates may not represent the due dates for your term, so make sure that you check your term to make sure that these are the correct due dates. So for this intro video, this is where you will find that, and you'll find that for each of your different modules. So for module 1, we're going to look at the overview, objectives, and the textbook reading preparation. So for this module 1, we will begin this module with learning about structure and properties of hydrocarbons. Then we will study IUPAC, nomenclature of saturated and unsaturated hydrocarbons. Then we will identify structural and geometric isomers of hydrocarbons. Finally, we will conclude this module by analyzing reactions of saturated and unsaturated hydrocarbons. Objectives. The student will be able to characterize structural differences between alkanes, alkenes, alkynes, and aromatic hydrocarbons. The student will use the IUPAC system to name hydrocarbons and be able to recognize their structural isomers. The student will be able to discuss combustion and substitution reactions of alkanes, and the students will understand the importance of hydrocarbons. And so your chapter for this reading will be hydrocarbons, all right, and the OpenStax. So this link will take you to the OpenStax textbook. It may ask for your login and passwords. You may need to register if this is the first time you're using OpenStax. All right. The supplement The supplemental online resources are videos that are meant to help you understand the material a little bit better. We are working with a lot of different organic compounds and their structures, and so these videos help you understand how to draw the different structures as well as how to look at the different reactions. So the first one is on hydrocarbons and their formulas, and then naming alkanes. Then we're going to look at structural isomers, and then balancing combustion reactions. And so very important that you look through these videos. They're not very long videos, less than 10 minutes, but they're going to really help you understand organic chemistry and how we do the naming, drawing the structures, and they're going to help prepare you for the assignments that you're going to be doing for this module. This is our first activity. So this is Module 1 activity, alkanes in everyday life. So the objective, this activity allows students to connect organic chemistry concepts to real-world applications by identifying how alkanes are used in modern society. Alkanes are saturated hydrocarbons widely used as fuels, lubricants, waxes, and industrial materials. In this activity, you will research and analyze one alkane and its role in everyday life. So you're going to select an alkane. Choose one of the alkanes that is used in everyday life. Examples include methane or propane. Draw the alkane. So you want to draw the structure of the selected alkane. You want to show all carbon and hydrogen atoms. You want to use correct single bonding because alkanes are single bonds, but you'll learn that in this module's information. Your drawing may be hand drawn or digital. you want to upload a clear image of your drawing into your assignment paper. You want to identify a real world use. So describe at least one modern application of your alkane. Examples include fuel sources, cooking gas, or candle wax. All right. So those are just some examples. It may not apply to the alkane that you choose. So you want to submit a real life image showing how the alkane is used in everyday life. The image must be relevant and appropriate. So, for example, a propane tank, a gasoline pump, or a motor oil container. So those are just some examples. Advantages and disadvantages. You want to describe both the advantages and disadvantages of using this alkane. So you want to consider efficiency or usefulness, the availability or cost, environmental impacts, the safety concerns, pollution or sustainability issues. So these are things that you consider when you're describing the advantages or the disadvantages of your alkane. So these are your submission requirements. Your submission must include the name of the alkane, the structural drawing, the description of real world use, the image showing your application, and the advantages and disadvantages in a discussion. Your submission should be 1 to 2 pages as either a Word document or a PDF. All right. And this needs to be a Microsoft Word document or PDF. Those are the only two forms of submission that are accepted. So no pictures, no any other Word type program. It has to be Microsoft Word. And remember, Microsoft Word is available to you free as an online student. And so there should be no reason why you can't place this in a Word document, all right? Or it could be a PDF. Either one is acceptable. And it needs to be at least 1 page or it's 1 to 2 pages in order to get your pictures and your descriptions and all of your information into this submission paper. All right. So we're going to go back to modules to show what is next for this module 1 activities. And so that was the activity. There is a homework assignment as well. And so we're going to click on the homework. All right, and so for the homework for Module 1, it's 10 multiple choice questions. There's no time limit on the homework, and you get 2 attempts. So you do the first attempt and say you don't do as well as you wanted to do. Before you do the second attempt, make sure you review the material and make sure that the things that you didn't do or understand completely, that you get those questions answered before you do the second attempt. All right. The higher of the 2 attempts. So, say for example, you get 6 correct on the first attempt, but you get them all correct, all 10 correct on the second attempt. The grade for your homework will be the second attempt. So, it'll be the higher of the 2 attempts. Right. So, keep that in mind when you're doing the homework. And then we have a laboratory assignment. So the Module 1 laboratory assignment. So each lab report should be downloaded and printed. Each page of the lab report should be signed with the student's name and the current date. All structures should be handwritten using color pencils when necessary. Students should pay extra attention to the details, and after completion, each page of the lab report should be scanned in color or a color picture should be taken of its content. Then the lab report should be uploaded, and that should say Canvas. I will update that. So you can get a printable version here if you click on this, and what it will look like, all right, is this. I looked at it previously, so done at the top. All right, so this is the printed version that you're going to print out and fill in the information. And here is what you'll see on the online version. With the online version, the difference is you get the videos, video links that'll help you. okay, to do the different parts of this lab. All right. You want to make sure that you answer each question thoroughly and that if you have questions before you submit it, that you reach out to me. All right. There's going to be some structures you're going to draw. There's the Kekulé structure, the condensed structure, and the skeletal structure. For this, the first structure, you see how the carbons and you see the bonds between the carbons and the hydrogens. This is the more detailed structure, right? Then there's the condensed structure where you group them into pairs. So in other words, this C is bonded to three H's. So we see we put CH with the subscript of 3. And then attached to that is another carbon that has two hydrogen. So we put CH2. And attached to that is another carbon that has three hydrogens. So we put CH3. This is the condensed formula. And then the skeletal structure, excuse me, that's the one where each point represents a represents a carbon. So there's a carbon here, excuse me, there's a carbon here, a here, and here. So there are four carbon in this one. And then if you think about carbon, carbon wants four things attached to it. So the carbons on the ends are going to have three hydrogen. The carbons in the middle are going to have two hydrogen, right? To complete that structure. So this is the skeletal, the condensed, and the Kekulé structures. And so for each of these, they're going to ask you for different structures. So they're going to give you one structure and then they're going to ask for the other two. All right. They're going to give you one, ask for the other. All right. And so if you have questions as you're going through these, one of these I want to show you this one, these two actually. So this one, this has a triple bond. So that's why you have these lines above. So there's a carbon here and a carbon here at these points, and then there is a triple bond in between them. That's what that represents. Down here, these are double bonds. And this is a ring, all right? And so when we have the ring structure, and it does talk about it in the video, when we have a ring structure at each point, just like before, there is a carbon. But if you see these two lines, that means there is a double bond, right? Here, there is a crosshair. At this point in the crosshair, there's a carbon. There's a carbon here, a carbon here, and a carbon here, all right? So just to give you a heads up on that one. Here's another example of what a double bond would look like, all right? And this is another example of a ring, but this is how it looks if we were to show each of the carbons within that ring. All right. So, like I said, if you have questions about these structures, it takes some getting used to and it takes some practice, but you will get it. And so, if you have questions, go through the videos, reach out to me. I can always do extra videos if you need. I can always work with you one-on-one to go through the information. But please don't go through the module and be confused and not reach out for help. All right. All right. Enjoy this module, and I will see you in module 2.